So, welcome to Prime Mathematics. Today we are going to discuss a problem 1.2, right? So, let's look this problem first. What's given in this? We have sine inverse this term as n pi by 2 given, right? Then what further we have? We have n belonging to natural number, and there's something called p given by this, and it is saying that this function fx is continuous at x equal to p. Then find the value of this. Means to find this we need to find p and we need to find k. So the first motivation is to find p and the second motivation is to find k. So let's see how to do this problem. So are you ready? Let's go. So if we observe the first thing which is given, the first thing is given as what? It has been given that summation r equal to 1 to n sine inverse ar is n pi by 2. Now if once person noticed that it is neither AP nor GP, it is some kind of sum. It's like a special sum. So there's no proper method to solve this. But there's a condition given that here the n value is coming from natural number. So if we observe the pattern, what pattern? If n is 1, it means r equal to 1 to 1 means it is the function itself. So when it's 1, then we have r as 1, so it means sine inverse a1, right? When n is 1 means we are going from r equal to 1, right? Sine inverse a1 is pi by 2. So what we observed that the value of a1 comes out to be as, for what value of sine inverse it's pi by 2? It is I think maybe 1, right? Sine pi by 2 is 1 means sine inverse 1 is pi by 2. So therefore we get a1 value as 1. Now in similar manner, if we take fn is equals to 2, so what we get? We get summation r equal to 1 to 2 sine inverse ar. Now this can be broken into sine inverse a1 plus sine inverse a2, and that is n pi by 2, right? So if we put n as 2, so we get 2 pi by 2, which is pi, right? And already we know that sine inverse a1 is pi by 2. So if you put the value, we get pi by 2 plus sine inverse a2 equal to pi. So pi by 2 minus pi means pi minus pi by 2 will be pi by 2. So there conclude that a2 is again 1, right? So what do you think? Next, a3 is also coming to 1. Let's check. If suppose n as 3, if n is equal to 3, we get from r equal to 1 to 3 sine inverse ar. So if we put r equal to 1, we get sine inverse a1. If we put r equal to 2, we get sine inverse a2. If we put r equal to 3, we get sine inverse a3. And this time, in place of n pi by 2, we will have 3 pi by 2, right? Because n value is 3. So if we observe, this is also pi by 2. This is also pi by 2. Pi by 2 plus pi by 2 is pi. So this will be cancelled out from 3 pi by 2 minus pi, which is nothing but pi by 2 again. So we conclude that sine inverse a3 comes out as pi by 2. So therefore we get again as a3 as 1. So we can observe one thing, that's in similar manner, similarly one can say that a4 is equals to a5 is equals so on up to an as 1, right? That is also equals to a2 and a1, means every value of a1 is coming out to be as 1. So from this, what we have the beneficial? We have the beneficial for p. Now p is a continued product. Now if we observe, p is pi product r equal to 1 to n ar whole to the power r. Now put r equal to 1, we get a1 to the power 1. If we put r equal to, we get a2 square. If we put r equal to 3, we get a3 whole to the power 3 and so on up to an whole to the power n. Since we know that a1, a2, a3 and all are these equals to 1, so if 1 to the power 1, 1 to the power 2 and so on up to 1 to the power anything, it comes out product as 1. Therefore, we obtain that the value of p is 1. Easy? Yes. So now next step is to find the value of k. So therefore, we got the point at which the function is continuous, means function is continuous at x equal to p. Now one can say this term as x equals to 1 because p is 1. So now what we do, we will just put, so now we have fx is given by, fx can be given by x to the power 1 by 3 minus 3 minus 2x whole to the power 1 by 4. And then in the denominator we have x square minus x, k, and x is not equals to 1 because p is 1, x equal to 1. So f is continuous at x equal to 1. By the definition of continuity, if x equal to 1, the function is continuous, one can say that limit x tending to 1, f of x will be f of 1, right? Or the definition of continuity. So when x is tending to 1, remember, when x is tending to 1, it implies x is not equal to 1. Therefore, we will select which function. So a piecewise function, the first function, piece, is very much appropriate to substitute in the place of fx. So in the placement of fx, if we substitute this value, we get limit x tending to 1, x to the power 1 by 3 minus 3 minus 2x whole to the power 1 by 4. Denominator we have x square minus x. Now how to solve this? That's a big deal. And what is f of 1? At x equal to 1, the value is k. So we are finding k, which we require to find. But one can find it this by limit x tending to 1. So one can just do a manipulation, right? If we replace as 1 plus x minus 1, what will be the beneficial will be later, you know, right? First observe, if we do a manipulation, 1 add, 1 subtract. And we change this as 1 minus 2 of x minus 1, right? Simple manipulation. What will be the benefit? You will know very soon. X common, so we get x minus 1. Now observe one thing, one small thing, is x tending to 1 means x minus 1 tending to 0. So if one can say x minus 1 as h, right? If we assume that x minus 1 is h, so one can say it as limit x tending to 1 will be convertible to h tending to 0 limit. So in replacement of wherever x as written, we can write it as x as h plus 1. So we get 1 plus h whole to the power 1 by 3 minus 1 minus 2h whole to the power 1 by 4 over 1 plus h dot h, right? Of course. So if we know a binomial approximation, what is a binomial approximation? 1 plus x whole to the power p via binomial approximation. So why binomial approximation? Whenever x is a very small, infinitely small, one can just simply replace it by 1 plus px, right? So if we observe h is tending to 0, of course 2h is also tending to 0. So 1 plus h to the power 1 by 3 can be written as 1 plus h by 3 by this form, right? And similar manner, 1 minus 2h whole to the power 1 by 4 can be written as 1 minus 2h by 4, which is nothing but 1 minus h by 2. So after substituting these values in this limit, we get limit h tending to 0. It will be 1 plus h by 3 minus 1 minus h by 2 all over 1 plus h dot h. So if you simplify this, negative sign will enter, 1 and 1 gets cancelled out. So we get h common, 1 by 3 minus 1 by 2. And in the denominator part, we have what? It will be 1 plus h dot h. So h and h cancel out. So if we just directly substitute the value as such as 0, so we get minus 1 by 6 in the numerator. Am I correct? Yes. So therefore the value of k is coming out to be as negative 1 by 6, and the value of p is 1. So what we need to find? We need to find simple expression like 6, value of p is 1, and value of k is what we have just evaluated. It is negative 1 by 6, right? So it will be 6 minus 1 by 6, which will be 6 times of 5 by 6. Answer is 5. This is your answer. Thank you, everyone.